All right, straight out of your book. Example 1. A stone released from a state, I forgot the E, of rest falls to the earth. Estimate the instantaneous velocity at t equals 0.8 seconds. Okay, so t equals that. Now first what we need is our gravity function, which they give us in this example, but I didn't write it up here. Let me write it for you guys. So here's Galileo's formula. It's S of t equals 4.9 t squared. Okay, so this is Galileo's gravity function here, right here. So a stone is released from a state of rest, falls to the earth. What is the instantaneous velocity at 0.8? Velocity. We're looking for wait, what's another word for velocity? Yeah. The other word for velocity is rate of change. And so I'm going to cross that dude out. And I'm going to write rate of change. But wait. What is another word for rate of change? Oh, slope. That's even better. Slope. So let's reread the question. Estimate the instant... Where's my S? Man, I can't type today. Estimate the instant... What the heck? Oh, no, that's an E. Okay, that's right? Instantaneous. Slope at t equals 0.8. Okay, we need to find the slope at 0.8. Now, that should be weird to you. That should be weird to find the slope of this. It's weird because that's not a line. That is a parabola. Okay? You guys remember lines? Like you would have this line right here, and then you go, oh yeah, rise over run, and there's my slope, right? That'd be no problem. And the thing with lines is that the slope is constant. It is always the same no matter where you go on the line. Right? Okay, now this is different. This is a parabola. A parabola. Okay, now parabolas, this one, I'm just going to draw a rough sketch. Whoa, that's really bad. Okay, oh, thank goodness for an undo button. Okay, yeah, still the same. I just drew the same thing 3 times. But you can tell at each of these points, the slope is different. What's the biggest difference between this side and this side of the slopes? This one is negative. These are all negative slopes, and these are all positive slopes. Right? Yeah. At each of those points, at each of these points, we can find a different slope. Now, as I go to each of these points, what's happening to my slope? Do you guys know? It's getting what? It's getting steeper. The slope is getting steeper and steeper, so therefore the slope is getting bigger. Now, I'm using the word slope, but I can say velocity instead. The velocity is getting bigger and bigger the farther away I go. Now, this question says, find the slope at 0.8. So let's make up a point right here. Let's say this is 0.8 seconds right there. Okay? This is t in seconds. I love visuals. They make things seem so much easier. So the slope I'm looking for is the slope of that tangent line. The tangent line at that point. What's the x value right there? Oh, that's 0.8. We need to know the slope right at that point. And so you know what we need to do? We need to find a bunch of other slopes, so you can see what this slope probably will be. So here, let me give you an example. We're going to keep this point, but then we're going to have another point up here, and we're going to find the slope of that line. Then we're going to pick another point, and we're going to find the slope of that line. And then we're going to pick another point, and then we're going to find the slope of that line. And then we're going to pick another point, and we're going to find the slope of that line. What's happening to the point each time? Getting closer and closer and closer. And so I have to find a number of slopes. Now let's make our jobs easier, okay? Can you guys just at least find 3 slopes that are really close to 0.8? So we need to pick some x numbers that are close to 0.8. Let's start at let's say 0.9 is the first one I start at. So those are 2 x numbers right there. I'm going to write my 2 x numbers like this. And then I'm going to write the slope for that equals. So those are my x numbers. How would I find the slope for those 2 x numbers? What would I have to do? Well, we could subtract the x numbers on the bottom, right? And what would I have to do on the top? subtract the y numbers. See, this is stuff you guys already know how to do, right? So use your calculators and throw these numbers into this, square them, and then multiply them by 4.9. So 3.136, that's what I get after I take 0.8 and plug it into the function. Okay, so I plug that into the function to get my y value, and then I'm going to subtract from that. What was the other one? 3.969. So now you have those numbers in your calculator. Go ahead and subtract those on the top, subtract the bottom ones, then divide it. Then tell me what you get. .33. Now I know that this should be positive because that line is positive right there. I know it should be positive because when I subtract the top I get a negative, when I subtract the bottom I get a negative, and a negative divided by a negative is a positive. And so I found one slope. Now I need to find two more slopes, but I need to pick points that are closer and closer. So I'm not going to pick 0.9 now. I'm going to pick a different one. Let's see. 0.8, and then the next one, what's closer than 0.9 to 0.8? 8.2, yeah. Okay, make it a jump. That's cool. 8.2. 0.82 is way closer to 0.8 than 0.9. So there's my two x values. Now I have to find the slope of this one. The slope for this one. What would that equal? And then I have to do it again. Let's see. 0.8. And then in the next one, let's do 0.81. Right? That's even closer. And then you find the slope for that one also. Same thing that we did already. And then 0.8, and then 0.8. What's even closer? 0.8. Ooh, 0.1. That's even closer, right? To 0.8. And so once you find enough, I mean, guys, this gets annoying really fast. Okay? But once you find enough, then make a prediction as to what the slope is, and then write that down as your answer. That's all you gotta do. That's it. So this is what it looks like. The slope when you find the first one that I have listed here is 7.938, and the next one would be 7.889 and 7.8449, and I went ahead and I did one more, so I did 0.8 and 0.8001, and that slope is 7.8405. So when I estimate the instantaneous rate of change, it would be 7.41, because I can see like there's a big, not really big, but a bigger jump between these two than between this one and this one, and an even smaller change to this last one. So I'm just going to take that last one and round it to the nearest thousandth. So I'm going to say that my instantaneous rate of change, or I should say instantaneous velocity, is 7.841.